to another learning session. How many of you are aware about what IP addresses are? Any answer should be fine. But today's session, I want everybody to be participating either in the chat or through voice. And then one more question: how many of you here are completely new to IP addresses or have very basic or little knowledge only? Just type N in the chat. Okay, we have people who are a little bit new to IP addresses also. Okay, so let us get started, and in the end, let me know those people who have been there and know IP address, as well as those who are new have learned something. Okay, so let me share screen. Okay, so can you see my screen?
Yes.
Yeah.
Okay, good. So let me show you something. So this before even starting the PPT and our class, so you see this domain name, right? Cloudrix.com. So every system in the internet has a IP address, but that IP address is in the form 192 dot something dot something dot something, or it could be even a bigger IP address if it is a different IPv6 scheme. We will look into those things shortly. But in any case, imagine that we have a numerical number, but that numerical number is difficult for us to remember. So therefore, we have something called as a domain name system that maps an IP address to a domain name, such as this one, cloudrix.com. And if you look into your Chrome's dev tools, and if you go to network, and if you execute any command, you can see that a lot of things are happening behind the scenes, right? So it is not just that, like you see here, you're making a request and immediately you are getting back a response. Lot of things happen behind the scenes. So it includes communicating with a server, and then a server responding back with a status. So this status is 200. 200 means success, right? Hope all of you are aware about the HTTP status codes, right? Success, redirect. Anybody who does not know about it? So behind the scenes, a lot of things happen, and those a lot of things make use of something called as IP address also, and it also makes use of something called as a port. Okay, port means you see this IP address here, right? 172.64.151.34 colon 443. So this 443 is a port. So a machine can be represented by an IP address, and a port number will be representing an application within that machine. Okay, so just showing you how things are working in real world, or how you can explore these things to get more understanding of IP addresses and what happens behind the scenes whenever you make a request to a web server. So that said, let us get started with our presentation for today, and then we will have a lot of practice exercises also to make sure you are 100% thorough about whatever we are learning here. So let me share again. Okay, IP addresses and subnets. So what will we learn today? What are IP addresses? IPv4 versus IPv6. Introduction to classless interdomain routing, and network identifier bits and host identifier bits, subnetworks and netmasks, and private IP addresses. And finally, we will also look into some questions to check your understanding of what you have learned today. If you are new to IP addresses, at least I have to assume that you have basic knowledge of computers and computer networks. You know about these things called binary, decimal, and hexadecimal numbers. You have some idea about adding binary numbers, and you have a basic understanding of OSI model and the TCP/IP model. Also, bit of understanding of router, switch, bridge, etc. are good to have, but none of these are mandatory. As long as you have a basic idea of all of these things, it is good to go. And if you need detailed sessions on this, you can always let me know, because this is a special class which is not part of our Azure or AWS syllabuses, right? This is just to make sure you have proper understanding of the prerequisites that are expected from you from the Azure or AWS modules. Okay, yeah, you know all about me, so I'll not go deeper into it. Okay, so internet protocol or IP addresses. So we'll be focusing on a little bit of a theory initially, and then we'll do into our hands-on practical things. Okay, at any point of time, if you have any doubt at all, please feel free to ask me. Stop me, ask me, make it clear, and then move forward. So internet protocol or IP address or IP addresses. So an IP address is a numerical label assigned to all devices connected to a computer network, such as the World Wide Web or Internet, or a local LAN network that uses the Internet protocol for communication. So when you go through the TCP model or the original OSI model, you will find that okay, there are layers where networking is talked about, and we have the IP protocol and all. So this is that IP protocol that helps us communicate with the different computer systems on the internet. I'll try to make things as much as simple as possible in this intro session. Still, if you are not able to understand, please feel free to ask me. I'll not say this reminder again. So remind and ask me. So an IP address helps in identifying the host and locating it on the network. So I told you, right? So IP address help you identify a host machine or a computer on the network. So to do that, so first it has to identify the host network, right? First it has to identify the network, and from within that network, it has to identify the computer. And this computer is generally referred to as host here, right? An IP address in general is divided into two parts, as we will see later. Some of the bits in that IP address is used to identify or locate the network, and in some cases also the subnetwork. We will see what network, subnetwork, etc. is, and rest of the IP addresses, right? Rest of the bits of the IP addresses are used to identify the host within that network. And there are two kinds of IP addresses. The traditional one is IPv4, which has been there for quite a long time. But what happened was that this IPv4, the number of IPv4 is limited. It is only 32 bits, right? So people started using it for all of their websites, systems, internal systems, external systems, everything. So initially it was very fine. Okay, initially it was very fine because there were only a few systems uh, connected and using internet, right? But now the situation is not like that. And because of all of these things, we also have this concept of private IP addresses. So how many of you are aware about private IP addresses? Okay, so most of you know about private IP addresses. So do you know the ranges for private IP addresses? The need for private IP addresses. So since this IPv4 is limited, if you if all the organizations, right? So currently we have lot of organizations So lot of organizations, enterprises, startups, lot of companies using internet for their employees, right? And if all of those machines needed an IPv4 address, then we won't have enough IPv4 address for all of these machines. And that is why we have a private IP address ranges. This means that within an organization, within their internal network, they can use few different IP address ranges, and that can be used by different organizations also. We will see those exact ranges shortly. And what is advantage? So I can use within my organization, I can use the same IP addresses that somebody else here, maybe Sham or Harsh or Arun, uses in their organization. But to the external world, you will do some translation so that they will see a public IPv address that is registered. Okay, clear? So the translation process and all will be little more clear when we move forward either on the AWS or Azure track. But that is how this the idea of public and private IP addresses work. And with IPv6, you have a lot of options. You are not limited to 32 bits. So now it will take a lot of time for IPv6 to get exhausted. I think we will not have to wait for it because it is going to be a very huge time. IPv6 has a lot of IP addresses. Okay, so coming back, IPv4 has 32 bits divided into 4 parts, and each of those parts are 8 bits each. So each part, also called as a octet, is represented in their decimal format, in not decimal format. Decimal numbers are separated by dots. So if you see here, 10 dot 12 dot 14 dot 16. So behind the scenes, this 10 is 8 bits. This 12 is also 8 bits. 14 is also 8 bits, and 16 is also 8 bits. And that is why I have been telling, okay, you need to have some knowledge about binary and decimal. So that 8 bits is a binary, and whatever you see here, right, 10, 12, 14, 16, these are decimal. But to actually do some calculations that we'll be doing later, you need to have some understanding of binary also, because most of the calculations happen as binary. Clear until now? And IPv6 address has 128 bits divided into 8 parts of 16 bits each. Each part hexads is represented in their hexadecimal form separated by colons. So if you see here, 2001 colon BB8 colon 0 colon. So these are all hexadecimal numbers, and then you have 16 bits in each of these, and you have 8 parts. You can assume the difference in the number of IP addresses in both of these cases. But in our examples today, we will not make things complicated. We will try to learn the concepts based on IPv4. But similar concepts will be applicable for IPv6 also. So first question for everybody, what is the maximum decimal number that any of the 4 parts of an IPv address can contain? 192.1.2.3. What is the maximum decimal number that any of the 4 parts of an IPv address can contain? So I need everybody to participate completely for this session. Okay, I need everybody to participate, answer everything, so that you don't have to watch this recording. You will learn everything from this session itself. Everybody. I don't want to call names like in college and all. By the way, I have people here from my engineering days as well as my school and +2 days. Okay, it is 255. So you have 256 options, but that 256 options starts from 0. So the maximum number is 255. Okay, an IPv4 address has 32 bits divided into 4 parts with 8 bits each. The largest binary number that can be represented by 8 bits is 1111 1111. And if you convert it into decimal, it is 255. And therefore, the largest decimal number that any of the 4 parts of an IPv4 address can hold is 255. So this is the biggest number combination. Okay, 255.255.255.255. So what is the largest hexadecimal number that any of the 8 parts of an IPv6 address can contain? So these are all pure mathematics. I need you to respond with either the answer or I need you to say, don't know. You don't have to type completely. If you don't know, just type D. Okay, it has mentioned 255. But 255, how did we derive on 255? If you look here, so when you have 8 bits, all of them are ones, then the decimal value is 255, right? In this case, we have how many bits? How many bits do we have here? 8 or 16? 16, right? So definitely it is not 255, right? So 16 bits, and that too, it is not decimal. It has to be in hexadecimal. So it is FFFF is the hexadecimal representation for the largest hexadecimal number that can be represented by 16 bits. Okay, so this is an example. Clear until now? We'll not be doing much practical exercises with hexadecimal, but still you need to understand these things to be a good IT engineer. But because otherwise you see a similar thing in one of your IP address ranges and you'll be confused, right? So you need to understand. You don't have to by heart or learn everything, but you need to understand, okay, this is how IP address 4 or IP address 6 work. Clear until now? Network identifier bits and host identifier bits, the most significant bits, okay, left side of an IP address are called as the network identifier bits, or the network prefix or the routing prefix and identifies a network or a subnet. I mentioned initially, right? So whenever we are given an IP address, it has two duties. One, some of the bits are used to identify the network where our computer is present, and then rest of the bits are used to identify the actual machine within that network. So it could be a network, or within that network we can create subnetworks. Those subnetworks are also called as subnets. Okay, so some of the bits are used to identify the network. In that network itself, we will include a subnet. So we can call it as network identifier bits or NID. And rest are used to identify the actual machine. We can call them as host identifier bits or HID. The least significant bits, the right side of an IP address, are also called as host identifier bits or host identifier, and specifies a particular interface of a host on that network. That interface and all, right? Don't worry, when we actually learn about cloud, we will see what are those interfaces from a cloud perspective. Now, just imagine that, okay, that machine itself is represented by an IP address. Classless interdomain routing. So classless interdomain routing, or CIDR, is a format that is used currently for representing an IP address range or a IP address network or subnetwork, etc. So whenever we are working with IP addresses within our virtual network on AWS cloud or Azure cloud, we will have to create networks within our cloud, right? So you'll have to use some formatting to say that, okay, for this network, I will be using this range, and for that network, I'll be using that range, right? So you need some way to represent a range of IP addresses, and this is one of the ways that is being used more today. And as you see in the next slide, there was another form of classification that was used before called as classful. Okay, it had like a class A where NAD had 8 bits and HID had 24 bits. Class B where NAD had 16 bits and HID had 16 bits. Class C, NAD had 24 bits, HID had 8 bits. And we also had class D and class E, which did not have NAD and HID separation. And class D is reserved for multicasting, and class E is reserved for future use. But with the CIDR, the address space is allocated to internet service providers and end users on an address bit boundary. So we'll see what is that boundary. So it is little more flexible. So CIDR is a little more flexible than class full, where it had a very rigid division. The problem was that you have to be in one of those brackets, and one of these ranges, right? Class A or class B or class C, and many of the organizations did not needed that. So here in this class A, class B, and class C division, what is the minimum number of hosts anybody can have in a network that they purchase, or network that is allocated to them? What is the minimum number of hosts they can have? Make your guesses. Today it is all about using your brain, making use of it after quite a long time. So if you are listening to previous slides itself, you will be able to say that number. So we have how many HID bits here? 8, right? We have 8 HID bits. So with the 8 HID bits, how many systems can I have in my network? Because each of those systems will need to have an IP address. So how many systems I can have in that network?
4.
For with 8 bits, only 4. Okay, with 8 bits, what is the maximum number that we can represent?
255.
255, right?
Yeah.
Yep.
251. I think 251 is the system.
Yeah. So yeah, that is specific to networking when we come. Okay. So don't worry about the reserved IP addresses and all. So we are purely looking these things today from a mathematical perspective. Okay. So we have 256 combinations, right? So we have 256 combinations, and the maximum number is 255. That means you can start from 0. So effectively, you can have 256 combinations, and there are some reserved IP addresses. And also, in certain cloud providers, there are some general reserved IP addresses, and certain cloud providers might reserve some more. So you will generally get around 251 that you can use. But from a mathematical perspective, what is the possibility? The possibility is 256, right? Agree? Okay, so mathematically, the possibility is 256. That means in this model, the minimum I have to purchase is 256. But with CIDR, the minimum is how much? What is the minimum here?
1
Yeah, 1, right? If you want only one
because
IP,
0. Yeah.
yeah, if you want only one IP, why to have more? Okay, so again, so now coming back. So this IP address ranges, right, in CIDR format. So in classless was there, but we don't use it much anymore. So now we'll be using CIDR. And in our Azure and AWS classes also, we'll be using CIDR for all of our network related calculations, for creating networks, subnetworks, etc. So understanding of CIDR is very important. In this example one, right? In this example one, you see an IPv4 representation 192.0.2.0/24. What does it mean? So what does the 24 mean here? Okay, so we learned earlier, right? So we learned earlier about NID and HID, right? So NID also called as a network prefix or routing prefix. So this 24 means NID. Okay, network identifier bits, or it could be a subnet identifier bits also. But in general, we will call it as network identifier bits. So this 24 means 24 bits are used as the routing prefix, and the rest, which is 16 bits, are available for host identification within the identified network. And in an IPv6/32 means 32 bits are used as the routing prefix, and the rest, which is 96 bits, are available for host identification. Clear until now? Yes or no?
Yes.
Okay. So now answer. For an IPv6 address, if NID has 24 bits, HID has how many bits?
8. 8.
Okay.
8.
Okay, everybody clear? Okay, answer faster from next time. Everybody in chat also, you can answer, right? Just numbers. Okay, for an IPv4 address, the total number of bits is 32. Therefore, if NID has 24 bits, then HID have 8 bits. So now for an IPv6 address, if NID has 32 bits, HID has how many bits?
96.
96, right? It is all pure mathematics. Okay, it will have 96 bits. And it was not just mathematics. You had seen the answer in the previous slide also. Okay, so let us continue. So just these are some of the sessions that we have in between, where if you just attend those sessions, you will learn. You don't have to watch recording later or go through it again. As long as you are participating, just make sure you are participating for this 90 minutes, and then you will learn it all. Okay, calculating the number of IP addresses in a network. The number of IP addresses possible within a network can be calculated from the number of possible combinations of the HID bits, which is 2 to the power of HID bits. For example, if the number of HID bits is 4, then we can have 16 different IP addresses calculated as 2 to the power of 4. Okay, this is where I said a little bit of mathematical knowledge can be helpful. In general, we cannot use two IP addresses from our IP address range. The first one represent the network ID, and the last one represent broadcast IP address. But however, cloud providers may have additional restrictions to this. And quick note about unicasting versus broadcasting. Sending message to a specific host IP address is called unicasting. Sending message to multiple hosts is called broadcasting. Broadcasting can be of two types again. Limited broadcasting refers to sending message to all hosts on the same network using the IP address 255.255.255.255. We saw this IP address earlier as part of one of the example, right? And also, directed broadcasting refers to sending messages to all hosts in another network using the directed broadcast IP address of the other network. The directed broadcast IP address is the last IP address within a network or subnet. So quick question, if the number of HID bits is 8, then how many different IP addresses are possible? Okay, it is 256, 2 to the power of 8. So now you know how to calculate, right? So you know how to calculate the number of bits. You don't have to make any guesswork. If the number of HID bits is 8, then how many IP addresses can we use? So you understood the differences, right? So previous question was how many IP addresses are possible. So now how many IP addresses can we use?
255.
Is it 255?
It depends.
So 2 is minimum reserved, right? So you can use 254 as maximum, but cloud providers mostly might reserve 3 more. So you will get 251, but we are not looking into cloud now, right? We are looking into core IP addresses. So whatever we can use based on knowledge you have gained from this session until now, without the knowledge of cloud, it will be a maximum 254. Okay, because two are reserved in any case, not just in cloud. Okay, and the concept of a subnetwork. A subnetwork or a subnet is a logical subdivision of an IP network. A network may be divided into subnetworks for easy maintenance and security concerns. The practice of dividing a network into two or more networks is called as subnetting. So can you tell me some practical use cases? Can you think of some practical use cases of dividing a network into subnetworks? Assume that I have a network within my organization where I will be deploying my web application. Consider trainso.com or cloudris.com. Assume that we are going to deploy it, or the project that we are working on, the points trade or our WordPress based project. Assuming that I will be deploying it into a network that is given to me, is there any advantage of separating it into multiple subnetworks? What do you think? I need everybody to try and answer. Let us make it a discussion rather than a one-man show, right? Just try to answer. Yeah, security.
If there is,
Yeah.
if there
Okay.
is any two departments, so in our organization there is multiple departments should be there. So finance and kind of things. So if we divide into the differentiate into the different subnets, so we can assign separate specific IPs to the specific departments, so that it can restrict, so no other department can access the another department.
Okay, so that we will not generally do using subnetworks. That we will do using different virtual networks itself. Okay.
Yeah, we
so,
learn.
yeah, we can. So my question is, for my application, I'm not worried about other departments or other applications. Okay, these are real world use cases, right? So that is what you have to try
We
to.
do load balancing, right? Like you have 5 servers, you can put all in the same network and do that, right? So that's normally.
Yeah. So yeah, load balancing again, it will be within one network, or it will be within one subnetwork itself, because all of those applications, all of those servers will be having the same application. So in general, it will be within one subnetwork or one network. But my question is, listen carefully. I have applications. So consider we are doing two live projects now. One is points.trade and one is the WordPress project. So both of these, let us take one of them, the WordPress project. So I need to deploy this WordPress project, or WordPress is something that has been developed by somebody else, right? Let us take our own product, which is points trade. Okay. So I want to deploy this points trade on a virtual network assigned to me, allocated to my team. So there is no question of other teams or other departments or anything. So this virtual network is allocated to me for this particular application. So now, to deploy this application into this network, do I need to create subnetworks? And if I need to create subnetworks, will there be any advantages? Just think. And if you, yeah.
Better performance.
Again, so here performance does not have much impact. It is load balancing and other things can happen irrespective of whether you are putting it within a subnetwork or network. How, from a security perspective, how you can make use of subnetworks? So think from the security perspective only now. Again, if you don't know, you can mention D. Otherwise, I will just wait indefinitely for your answer thinking you are thinking. Otherwise, you can always make your guesses.
So when we do a subnetworking, our project will be isolated from the other networks, so it is more secured, right?
No. So even without subnetworking, our project will be isolated from other networks because we are having our own network for our project. So think. So this is one session I need everybody to think, not just now, because later for doing the mathematical problems, your brain has to be ready, right? So that is why I'm asking now to start it now itself.
Maybe we can assign RBAC there as well.
No, It is not related to Azure. So now we are so not thinking about Azure perspective. Okay, it is related to what you said, but again, it is not a role-based access or anything. Okay, let me only provide some. There are few people who are still thinking. They have not said D, not any answer. So either say D or say an answer. Otherwise, I will wait for you.
If fallback, if someone hacks, then I don't know.
Yeah, it is related to that. So when we were kids,
Fallback.
not fallback. Actually, it is related to someone hacking access and all those things. So you are closer, but not at the right point. Right? When we were kids, we used to play a game where somebody will hide something, okay, somewhere in the courtyard and all. And whenever we move closer to it, they will say hot, hot. And then whenever we are moving,
DDoS.
uh,
DDoS.
not exactly, it is closer, right? Okay, so let me tell you. So this is mostly from an application architect perspective. Okay, so whenever you are moving from 104 to 305, you will definitely need to know, at least for real world work, right? So whenever you are developing an application, you will have different components, right? You will not be deploying everything into one server. That is the first hint. Second, you will be having your web application deployed into a web server. Most probably you will have a separate server for your databases. Okay, and do the end users, people from internet, need access to your web servers? Yes or no?
No.
Yes.
Web
Otherwise,
server- web server-
otherwise,
Okay, sorry, yeah.
yeah. I usually ask the opposite question. So I thought I will change the question so that at least some of you will say no. I usually ask about database servers first. Okay, now I changed. Okay, Shyam, you are saying something?
No, I was saying that web servers need to be accessed from outside, but the other servers need not be known to the end users.
Yes. Okay, so there will be a lot of applications, right? So there will be, so whenever you are building, so as a architect, once you become an architect and you are architecting different applications for your team, then what you will be doing is you will be creating some diagrams. So there are many sites for developing these architectural diagrams and all, and then you'll be categorizing your applications into different subnets based on who will need to access it. So the very simple example, so this is a very simple example, right? A web server and database server. But in your actual application, you will have a lot of different components, and you will have to think about a lot of different access scenarios. So whenever you give access, you always give access to only people who really need it. The least privilege policy, right? So what does it mean here? You will have a web server that can be put in a subnet. So all these subnets can have their own security configuration, right? So different cloud providers will provide you different ways to configure those things. What all IP addresses or ports are allowed, what all are not allowed, who can communicate, what data can go out, all those things. The inbound and outbound can be configured. Inbound and outbound security can be configured at a subnetwork level by in most of the cloud providers, right? So you can configure that, okay, for my web server, inbound internet access is fine. And for my database server, inbound internet access is not needed. It need only access from the web server. You communicate with your web server, and your web server will communicate with your database server. So the subnetwork of the web server will allow internet access, but the subnetwork of your database server will not have internet access. Clear until now?
Yes, certain.
Okay, this is a very simple use case, right? So now let me ask you something which is a little more on the cloud side, but again, not needed for today's session. So these database servers do not have internet access, right? So if I am working from home or some place, and if I need to access these database servers or some server within these networks without a internet access for some maintenance or some activity, how can I do it? These things you will learn. We have labs also in Azure and AWS and also.
From dumb host.
Yeah, we have jump hosts. So some people call them as jump hosts. Some people call them as bastion hosts. Okay, so we have a machine where we can log in, and from that machine we will be able to log into these machines to do certain things. So the advantage is that if somebody feels like, okay, things are not good, you have to stop access only at the jump host or bastion host level, not at all the servers. Assuming if we had given access to all the servers from internet, then there will be a lot of places we'll have to look. But here we have one place for restricting access or checking the access logs and all those things. Okay, so we will not go into jump host, but I needed to say how real world projects or engineers work on these things. Okay, so coming back, clear until now, clear until networking, subnetworking, and the need for subnetworking. This one, at least I need a why from all of you. If it is not clear, you can simply say D. I will explain again. Okay, good. So subnetwork 1, you can have web servers. Subnetwork 2, you can have database servers. So here subnetwork 1, subnet 1 is a public server, public subnet, and subnet 2 is a private subnet. So you can configure all these things at the subnet level. And how to configure, that is what we are going to learn in our Azure and AWS classes, right? Or even in GCP classes when we start them in the future. Okay, so NID and HID bits with subnetting. The IP addresses for networks with subnets are logically divided into two parts: the network and subnet identifier, also called as the routing prefix; the host identifier, which is also called as the rest field. Okay, with subnetting, additional host identifier bits are used for subnet identification, and the routing prefix will now consist of both network and subnet identifier bits. But for calculations, we'll just call them all together as NID. Computers that belong to a subnet are addressed with an identical routing prefix. So all of them will have the same routing prefix, which represents their network and subnet. Okay, so just a pictorial representation. So IP addresses, you have network identifier and host identifier. And now you have subnet identifier and host identifier also. Okay, so routers, good to know. Routers are special gateway computers that allow us to do selective routing of IP addresses across multiple networks. Routers create borders between the subnets and manage traffic between them. Each subnet is served by a designated default router, but may consist internally of multiple physical Ethernet segments interconnected by network switches. It's bit out of syllabus, so don't worry if you have not understood about routers. But in case if anybody is interested in preparing for exams such as Network Plus or Security Plus or other exams, you can always get in touch with me. I'm also preparing for some of them, so maybe we can do a combined study. Netmask. Netmask is a bit mask in dot decimal format that when applied to a bitwise AND operation to any IPv4 address in the network yields the routing prefix bits. Netmask consists of leading ones corresponding to routing prefix bits and zeros corresponding to the host identifier bits. Example, 255.255.255.0 is a subnet mask in a dot decimal format for the prefix 198.51.100.0/24. All those calculations will be a little more clear when we do more examples. Netmask is a value that is used by routers to calculate the routing prefix network identifier for a network from an IP address. So this is where I mentioned initially to actually understand these calculations. Before doing all these calculations, you'll be converting all these numbers into binary, right? So you'll not be adding 198 with something, right? First, you'll be converting it into its corresponding binary, and then you'll be doing these calculations. So 255, it means all ones, right? So just simple mathematics. What is 1 and 0? Pure mathematics. What is 1 and 0?
Binary.
A binary 1 and 0. What is it? You remember about the logical operations, right?
1
Yeah.
0 and operation will be 0.
Yeah. So yeah, Priya has mentioned 0. Harsh has mentioned 0. So 1 and 0 is 0, because if you add anything with 0, it will be 0. And what will be 1 or 0? It is not needed here, but just to make sure. What is 1 or 0?
1.
Yeah, it will be 1. Anything you or with 1, it will be 1. Okay. So just remember those things whenever you are like doing these labs. So internally, all those logics are what your computers will use, making use of this subnet mask and all to identify your network and subnetwork, etc. So consider the CADR notation of 10.0.0.32/24. What will be the routing prefix? So what will be the routing prefix bits here? Just try to answer. You can answer in the chat.
255.255.255.0.
So what is the question? Consider the CADR notation 10.0.0.32/24. I'm not asking about subnet mask here. I'm asking about the routing prefix or the network identifier bits here. I'm also not asking about the number of network identifier bits, but what are the network identifier bits here?
Network identifier would be 8 bits remaining.
Yeah, so network identifier bits are represented by that /24, right? So what will be it? What will be the network identifier bits here? So few people have mentioned first two, all four. So how many bits each of these dots can have? 8, right? So what is 24 by 8? 3, right? So here 10.0.0, the first 3 octets, right? So they represent the network identifier bit, right? Let us see. So the IP address 10.0.0.32 can be represented in binary as all those ones and zeros. So the network mask for this block would be what? So /24 means all 24 from the left side will be ones in the case of a network mask. And if we do an AND operation on both the binary representation, what will happen? It will be 10.0.0.0. It will be only the first 3, right? 10.0.0 is the network identifier bits. But when you specify it as an IP address, it has to have all 4. So I think only Sham gave the right answer, right? So you have to understand that, right? So 24 means it is the left side. So you have the net mask means you have all 24 ones on the left, and then you AND with any whatever IP address you get, and you will get the network identifier. Clear until now? Because all steps are important. If it is not clear, I will explain again.
Hartin, could you explain the third step again, please?
Could you please explain
The
this?
third point, sorry.
It will be a little more clear when we go to the first IP address and last IP address range. But if I want to get the network representation, okay, what I will do, I don't care about the last 8 bits. So here last 8 bits have 32. I don't care about it. What I care about it is only the first 3. So first 3, here it was 10.0.0.32, right? Imagine it was 10.10.10.32. So what would be the dotted decimal format for the network then? Try to answer, then it will be a little more clear. So if the IP address was 10.10.10.32, what would be the dotted decimal format for the network?
I guess 10.10.10.
Yeah, 10.10.10.0.
Dot zero, yeah.
Yeah, because last one does not matter for us. Because the subnet mask only, so this is a network mask, right? So whatever you, whenever you add this network mask with any IP address, it will return you the network's ID. Clear?
Yes.
Okay, anybody else? Any doubt? Because internally, all these network components will have to do some calculation to allocate the right network, right? To route or forward your request to the right network. Then only all the other things will come into picture, right? Finding the right host within that network. Clear? One yes from all of you, if it is clear. I know it will not be 100% clear until you see the rest of the things. At least whoever is 99% or 98% or at least 90% clear, you can say yes. And in the end, I will again ask after all our exercises. Okay, so quick question. Consider the CADR notation of 10.0.0.32/24, where 24 is the subnet mask. If you use 2 bits for subnet identification, then the subnet mask /24 for the subnet becomes what? So this is the network mask. If we add 2 more bits for subnet identification, what is 24 plus 2? And how many bits will now be available for host identification? So total is 32. You cannot go beyond it, right? So total is 32. Within that 32, if 26 is used for network identification, what is left for host identification?
6.
Yeah. So clear until now? Yeah, I agree. Sometimes you may have to watch it again one more time, maybe. But at least for now, is it clear? Otherwise, I will explain again. Okay, all these yeses are actually making sure you are learning more. It is not because you are communicating, because when more than one of your senses, so this is proven scientifically, when more than one of your senses are getting involved in an activity, you will see more results. For example, if you are watching a session, and if you are watching a session and preparing notes, even if you don't read that notes or look into that notes ever again, it is still beneficial than simply watching a session, at least in my personal experience. Okay, which is a bigger network of IP addresses? I want everybody to answer quickly. /24 or /26?
/24.
24. 24.
Okay,
24.
so anybody here who does not understand it? Which is bigger, /24 or /26? Answer is /24, right? If anybody does not understand it, you can quickly mention D. Or if you understood, just mention 24 again. Because the advantage of a live session is that you can ask doubts. If you don't ask doubts and make it clear, thinking what others will think or how others will feel about taking that extra time, you will not learn. You have to be a little bit selfish when attending live sessions. Make sure you understand. Okay, so it is simple logic, right? How do you consider whether a network is big or less based on how many IP addresses it can hold? And /24 means for holding IP addresses, I have 8 bits, combinations of 8 bits. And for /26, I have only combinations of 6 bits. So /24 is a bigger network. Clear?
Yes.
Good. So I want everybody to say yes for these sessions because
Can you please explain like for 26 how it is 6 bits?
okay, so we saw here, right? 20
Oh,
total is 32. So if 26 is used for network identification, what is left? 32 minus 26, which is 6.
okay.
Clear?
Yep.
Yeah, good. Because if you had not asked that question now, it would have been there in your mind now, and you will try to figure it out. So that is human psychology, and then you will not be able to understand the rest of the things. Okay, coming back, /24 is a bigger network than /26. Bigger the size of the subnet, the subnet mask will be smaller and vice versa. Okay, so private IP addresses we had quickly discussed earlier, right? Private IP addresses are not allocated to any specific organization and may be used without approval for the lands in residential, office, and enterprise environments. IP packets originating from or addressed to a private IP address cannot be routed through the public internet. Private IP addresses were originally defined to assist in delaying the IPv4 address exhaustion. And see, these are the ranges as per RFC 1918, 10.0.0.0 to 10.255.255.255. Also 172.16.0.0 to 172.31.255.255. And also 192.168.0.0 to 192.168.255.255. So within your organizations, wherever you work, your internal systems should most probably have one of these IP addresses from one of these ranges. If you have not noticed, next time when you log into your company network, you can check. And we will also follow the same within our virtual networks whenever we are learning virtual networks in public cloud. More notes on private IPv6 addresses. Private IPv6 addresses consist of IPv6 addresses in the range FC00::/7 referred to as a unique local address or unicast addresses, but contain a 40-bit random number in the routing prefix to prevent collisions when two private networks are interconnected. May be used freely without centralized registration inside a single site or organization or spanning a limited number of sites or organizations, are routable only within the scope of such private networks, but not in the global IPv6 internet. In IPv6, the block FE80::/10 is reserved for IP addresses. Link local auto configuration. Again, don't worry about these things. We will discuss IPv6 in a different session. Okay, some questions to check your understanding. It is not over, right? With the questions, we are not going to. It is not going to get over. We have some interesting problems also to solve. Okay, but try to answer all of these questions now. Provide the range and number of IP addresses in the address space 192.168.0.0/24.
192.168.0.1 till 255. 254.
Okay, so here I am asking about range. So it is
0.1 till 255.
Okay.
Oh, sorry, sorry.
Okay, so it will be again, don't think about cloud or those things or reservations and all. So just think mathematically. Okay, so number of available IP addresses, it is 256. The range will be from dots or 0 to 192.168.0.0 to 192.168.0.255. Clear? All of you? Okay, good. Consider this IP address space 192.168.0.0/24. Divide it into two equal subnets. Yeah, this you will need to use a pen and paper. Think well. You can do your calculations. Divide it into two equal subnets. So tell me, before dividing, how many IP addresses are there in this particular, or how many IP addresses are possible in this particular IP address range, 256. So if you are dividing into two, it will be
128.
128 each, right? So tell me the two subnet IP addresses. So this is something that you will need to use while you are working with Azure or AWS cloud. You'll have to provide a number like this, 192.168.0.0/24 kind of a number. You have to provide two such numbers, two ranges, okay, two CIDR notations for the two subnets. There should be slash something.
/25.
Yeah, it will be anyway. It cannot be /24, right? And it is smaller than this one. So it will be definitely /24 or so /25 or above. So that guess you can make, right? So it will be /25. There will be two /25 ones. So what are those two /25 ones? You have to think, because in cloud, if you want to do networking, you will have to do these things. Normally in cloud sessions, people directly jump to Azure syllabus, right? Or AWS syllabus. But I want to make sure you know these things. That is why we are having this special class. So make sure you understand and learn now itself. Okay, Amit has mentioned 192.168.128.0/25, 192.168.0.128/25. Anybody else? Anyway, you have to give answer in this format. That is for sure. I'm not saying that this is correct or not. Actually, there are a lot of other calculations also I had planned. So maybe we can do it in a follow-up session. So you will. So personally, I also have done these calculations to make sure you know the steps to actually do it. Okay, this is a very simple one. You don't have to do any of those calculations. That calculations are for different purpose to understand it much more deeper. Okay, Sujin has mentioned 192.168.0.0/25, 192.168.128.0/25. Okay, so others, please try. If you are making a mistake, it is fine. I'm not going to do anything. Just give it a try. So those who have given up, just type G so that I will not wait for you. And if you haven't understood, then also you can say. So here it is, we have to divide into two equal subnets. That is clear for all of you. And /25 was also clear for all of you. So what is the starting of the first subnet? It will be same, right? It will be same because you have 128 IP addresses or 256 IP addresses. So first 128 will be part of one subnet and rest 128 will be part of the second subnet. For the first 128, it will be same, right? Only thing will be instead of /24, it will be /25. So first one, I don't think any confusion is there, right? It will be the same, but with /25. That means, and second one, where will it start? First one has how many? So first one has how many IP addresses?
128.
128. And when you say 128, what is the maximum number that you can represent there? It will be starting from 0, so it will be 127, right?
127, yeah.
So what is the starting for the next range? So 0 to 128, right? 0 to 127 went with the first set. So the second set will start from 128, right?
Yes.
Okay. So try to understand, because this is something that you will have to do whenever you are designing IP addresses, right? Sometimes cloud provider will automatically show you hints and all, but why to wait for that? Okay, this one, if anybody has not understood, that means you have not understood the rest of the things clearly. So I need to make sure you answer this. And make sure you are clear with this. I will probably defer these calculations to a follow-up session. Those are also pretty much interesting things. It will make you 100% clear about all of these things. So now tell me, are you clear about this calculation? If not, you have to say D. If you are clear, you have to say C. Everybody has to answer, because if you have not understood this, then this whole session is of no use, right? And I'm more than happy to explain it again. So total, you have 256 IP addresses. And when I say divided by 2, it will be 128, 128. So the starting will not change. Earlier, it was from 192.168.0.0 till 192.168.0.255. Now, we are going to split it into two. The last one was only a variable, right? So last one had 256. Out of the 256, if you divide it by 2, it will be 128, 128. So first 128, 192.168.0.0 till 192.168.0.127 will be part of first subnet. And what will be the starting of the second subnet? It will be 192.168.0.128 till 192.168.0.255. Clear? Else you can say. Who has not shared C or D? Okay, everybody have shared either C or D, right? No D, right? So shall we proceed? Can you take a screenshot of this? Okay, consider this address space 192.168.0.0/24. divide it into 3 subnets with following sizes: 64, 64, 128. I need all of you to calculate and answer in the Keva study group. Okay, once you are done with the session, I want all of you to answer in a Keva study group. So here there will be 3. Okay, I'm not giving any more clues. Based on your understanding, you have to calculate and answer in the Keva study group. So let me pause share and then move to the next question. So this will be an assignment. Okay, so this is an easy question to wind up. Provide the range and number of IP addresses in this address space. This is a very easy question, right? 192.168.0.0/32. Provide the range and number. You have to provide the range and number. So there will be how many IP addresses here? 1, right? So range is same only. Okay, clear about this? So what is 2 raised to 0? It is again pure mathematics. What is 2 raised to 0?
1.
1, right? So 2 raised to how many is pending? That will give you the answer. So here it is 2 raised to 0, which is 1. Okay, what is 2 by 0? Out of syllabus.
0.
Tell me what is 2 by 0? Everybody, it is completely out of syllabus.
That's infinite.
Okay, yeah. So infinity, right? So yeah, so it is good to revise mathematics that we learned in school, college, engineering and all. Okay, so post assignment, somebody can take a screenshot of this. Provide the range and number of IP addresses in the address space 192.168.0.0/16. Okay, question number 2. Consider this address space 192.168.0.0/16 divided into 2 equal subnets. And assignment number 3. Consider this address space 192.168.0.0/25. Divide it into 3 subnets with the sizes 32, 32, 64. All of these things you will have to do when you design your network, right? So this is a prerequisite session, but there is a follow-up session for this where you will little bit more go deeper into these things with complete problem solving. How many of you feel like you have learned at least something useful today? Okay, and how many of you would like to attend the follow-up session also, where I'll not be sharing anything from the PPT, but I'll be using my tab to write, and you will also be using your pen and paper to write to make things more than 100% clear. But as of now, all of you are clear, right? So assuming you don't have any doubts, shall we wind up? If you have any doubt, I will stay back. For now, I want all of you to spend some more time in finding the answers of the assignments and sharing it in the Keva study group. Okay, do you agree to do that now itself, or do you plan to procrastinate? Okay, I think people for US, if you want, you can do it when you get up also. But others, do you give me a promise that, okay, you will do it and not forget about it? Okay, yeah. So Harsh has mentioned he will do it, even though it is a little bit late for him. So others should definitely do it. Okay, please do and share it in the group. It could be you can even write it in a notebook and share like this a picture of it. It is also fine. It is very simple exercise, right? So, but please do share as soon as possible, if possible, immediately. Assuming there are no more doubts or questions, bye bye for now, and see you all in the next class. And do share your feedback about the classes in the Keva study group also, so that others, because if you see like whenever you say special classes, people think that okay, it is not needed. I need only Azure or AWS. But do you think these special classes are actually useful? Okay, so if you feel useful, you can mention in the group so that others will. Anyway, it is available for all, right? But still, people think that okay, if it is out of syllabus, then I will not attend it. But if you want to become a real engineer, a real cloud engineer, and excel in your work, it is always out of syllabus. You cannot say that I have learned only 104 syllabus. I will only work on that. That will never happen. You need to learn a lot of things outside syllabus. Okay, so please share your feedback in the group, and then maybe it will motivate others to join. So, but before now, and